Hello, my name is Devin, and I'm a part of the Challenge Program of 2017. Right now, I'll be teaching you a quick lesson on unit circles. Now, I know you're probably thinking, why at this time of the day would I try to teach you unit circles? Well, it's pretty simple actually. You kind of need a unit circle if you're going to do trig functions. Now, the mathematical definition of a unit circle is a circle with a radius of 1, centered at the origin. Me personally, I'd like to think of it as a pizza, or maybe a pie if you like pies. I'm more of a pizza man, pepperoni. Um, we're gonna take this pizza. We're gonna refer to the unit circle as a pizza for now. If you get hungry, I'm so sorry. You have 4 quadrants in this. Kind of break it up into fours, where it goes from 0 to 90, 90 to 180, 180 to 270, and 270 to 360 in terms of degrees. Inside of these quadrants, you have different angles. Today we'll be focusing on quadrant 1, which is from 0 to 90 degrees, in which you have 3 distinctive parts: a 30-degree angle, 45-degree angle, and a 60-degree angle. Now, trig ratios in quadrants are computed in terms of x, y, and r. Now, x and y are pretty self-explanatory, but r is known as the radius or the hypotenuse. So, you got x going up the bottom, you got y going up and down, and you got r or h as your hypotenuse. Now, an easy way to, or I should say, quick way to understand if a hypotenuse or a triangle is going to fall on a certain degree, you would use the unit circle. So, say that I have a 3 as my x and a 4 as my y. Then we would easily be able to figure out what the hypotenuse is. And an easy way to come up with that is to use the Pythagorean's theorem, which is x squared plus y squared equals z squared. But in this case, it's going to be 1. So back to the distinctive parts that are in quadrant 1, 30, 60, 30, 45, and 90. 60, excuse me. We also are able to label it as pi if you're going in radians. So if you're going in degrees, you would of course say the degree, 30 degree. But if you're going in radians, you would say pi over 3, pi over 6, pi over 4. And it's just an easier way to understand what you're talking about. Pi in this case in radians would mean 180 degrees. So 180 degrees over 6 would be 30 degrees. 180 over 4 would be 45 degrees, and so on and so forth, except we would now be referring to it as pi. So, to give you an example of what I mean when I say you can use the Pythagorean theorem to figure out if the hypotenuse is going to be a certain number. For one thing, you always want to remember is that whenever you're dealing with the unit circle or trig functions, if your x and y points fall on the circumference of the unit circle, then the hypotenuse or the r will automatically be 1 every time. And you can use the Pythagorean theorem to prove that. So for example, we're going to take 1/2, that's going to be our x, and square root of 3 over 2 as our y. I don't know if you have any paper and pencil, I suggest you do, but I'm just going to do a little mental math in my head really quickly. So 1/2 squared would be 1/4, and you would add that to square root of 3 over 2, which would just be 3/4. So 1/4 plus 3/4 is 1, and that shows that you have the answer. I'm sorry, for lack of a better term. You have your hypotenuse. You have your evidence. There you go. You have your evidence to prove that hypotenuse is 1 and that it falls on the unit circle. Another example would be square root of 2 over 2 squared plus square root of 2 over 2 squared. So that's pretty easy since it's the same number. So square root of 2 over 2 squared would just be 1/2. 2 over 4, 1/2. So 1/2 plus 2 over 4, 1/2 would just be 1. That's another example of how Pythagorean theorem was used to show that it's in fact on the line.